for a second here for the recording. So when we're doing synthetic division, we can only divide. So we can only use synthetic division when we've got a linear polynomial on the bottom, which means the biggest power of x is x to the 1. If it were bigger than x to the 1, like x squared or x cubed, we would have to use polynomial long division. Okay, so then here's one way to set this up with a bracket. This is kind of a nice way to do it. It's a good way to keep track of the process. We're gonna draw our big L-shaped bracket, and then outside to in the top row to the left of the bracket is the 0 of the denominator. So the value, if I set the bottom equal to 0 and solve, whatever number that is, and then to the right inside the bracket, the top row would just correspond to all the coefficients of x, starting with the biggest power of x and ending with the smallest power of x. If you are missing a term, then that means you have to have a 0 coefficient for that power of x. In this case, we're not, though. So we would have 5, 11, 3, 6, and 8. Okay, and then the process just goes like this. The order is, we'd start off with nothing else in the bracket. All the stuff in yellow is stuff that we haven't done yet. So the first thing you do is you take the first number, the first coefficient. So the first number inside the bracket, and you drop it straight down underneath the bracket. Okay, so the 5 drops down. Now, whenever a number drops below the bracket, the process is always the same. So in this case, we have a 5. We're going to multiply that number by whatever the number is outside, the 0 of the denominator. So 5 times -2 is -10. And then we're just going to push that up into the next row inside the bracket. And then we just add those numbers. Okay, so in our case, we get 5 times -2 is -10. And then we have 11 plus -10. With synthetic division, you always add the numbers vertically, which is the opposite of what you do with long division. Long division, you subtract. So 11 plus -10 is 1. So there we got another number that drops below the bracket. So immediately when a number drops below the bracket, we multiply by the outside number. So 1 times -2 gives us -2, which we push over into the next column. 3 plus -2 is 1. So we get another number outside, another yellow number. 1 times -2 is -2. So we push that over into the next column, which we add to the 6, and we get a 4. 4 times -2 is -8. And then we add the vertically, and we get 8 plus -8 is 0. So what that means in this case is there is no remainder when we do this division. Okay, so our answer then, our answer shows up in 2 parts. There's going to be the part here that was formed by the numbers 5, 1, 1, and 4. And then something else I forgot to mention. When we make our bracket, whatever the constant is in the polynomial that's in the top of the one that we're dividing into, below that we're always going to make a box when we make our bracket. And that's what we call the remainder box. So in this case, there's no remainder. And the numbers to the left of the remainder box, those are just the coefficients of x in our answer. Okay, so the number that's immediately to the left, in this case the 4, is always going to be the constant in our answer. And then what I always tell my students to do is just start there and work your way up from there. So that's the constant. The next number is the coefficient of x. The next number is the coefficient of x squared, and the next number is the coefficient of x cubed. So our answer is just 5x cubed plus 1x squared. So we just write that as x squared, plus 1x, which we just write as an x, plus 4. Okay, does that make sense?
Yeah.
Okay, so now let's do another one. Let's do one where we actually end up getting a remainder. Okay, so what about one like this? So here we've got 3x to the 4th minus 5x squared minus 2x divided by x plus 3. Okay, so now I'll tell you what, you tell me here what, well, just try this, kind of work through this on your own, Tyler, without looking at the screen for a second, okay? when you've got the bracket written down, why don't you hold it up for the camera and let me see it?
Okay. So be negative. Can you see it or not?
Yeah, I can. -3. Yeah, good job. That's it. Okay, good. Okay, so now go ahead and work through that and let's just see what you get.
Okay.
While you're doing that, I'm going to grab another example here.
Okay. So I got, you tell my answer.
Okay, yeah, here, let's take a look.
Okay. I got 3x cubed minus 9x squared plus 22x minus 68 with a remainder of 204.
Right, so then the way you would write that, go ahead and look at the screen then. So the remainder of 204 then,
goes over x plus 3.
Right, right. And the way you remember that, remember the remainder is always what remains over the denominator.
Okay.
Okay, is that good?
Yeah.
Okay. So then let's look at another one. I'm going to pull one up. It's kind of nice if I can point to my notes here. Let me grab one real quick. I got to find these. I don't have these named as well as I should, I think here. Let's see. Okay. Give me just a second.
Okay.
Okay, let me see. One of these does what I want it to. Okay, yeah, I found one. This is good. Okay. So can you're seeing my screen?
Yeah, I can see the equation.
Okay, so you want to do one like that too, right?
Yeah, I'm doing those too.
Okay, good. Yeah. So the way when we do synthetic division, what we have to do is the denominator always has to look like x minus a number, and the number could be negative, which is the same as x plus a number, right? So it always have to be either x plus a number or x minus a number in the denominator. It can't really look like 2x plus a number. That make sense?
Yeah, it has to just be x minus something.
Right. Okay. So what we can do then, remember now, when I've got a fraction like this, as long as I treat the top and the bottom the same, that's legal to do algebraically. So what I could do is I could just divide the top and the bottom each by 2. Okay, which is the same thing as factoring a 2 out of the top and the bottom. They really mean the same thing. When I factor something out, factor out a greatest common factor, in this case, we're forcing a factor that isn't really there. Like in the bottom, for example, if I were to undistribute a 2, what would I have left? The first term, I would have whatever I get when I divide that term by 2. Well, 2x divided by 2 is just x, right?
Right.
Okay. 5 divided by 2 is 5 halves. Okay. And then I would have this 2 out in front. Does that make sense? Because I factored that out. Okay. So on the top, what would I get? Well, 2x cubed divided by 2 is just x cubed. Negative 11x squared divided by 2 is negative 11 halves x squared. Negative 50x divided by 2 is negative 25x. And negative 27 divided by 2 is negative 27 halves. Right?
Right.
Okay. And then I factored the 2 out. So I've got this 2 out in front. Well, now look, I've got a 2 on the top that's being multiplied by everything and a 2 on the bottom that's being multiplied by everything. So I could just cancel those 2's. 2 over 2 reduces to 1, right? So Tyler, a shortcut for that then would be, instead of using factoring, and you can kind of take your pick, these mean the same thing. Mathematically, this is the best way to show it, but what you really could do is you could just say, okay, well, let's just divide the top by 2 and the bottom by 2, and that would give us everything in white here.
Right. Okay.
Okay.
Do normal synthetic division.
Right, and now we would do normal synthetic division. Exactly. Now, what's a little odd about this is I've got fractions in there, but that's okay. That's okay. So then we end up with, so we got our coefficients. The number out in front, the 0 of the denominator now would be negative 5 halves.
Mm-hmm.
Right? And my coefficients would be 1, negative 11 halves, negative 25, and negative 27 halves. And then I'll put my remainder box underneath the constant. Okay, then we just go through the regular process. We drop the 1 down. 1 times negative 5 halves is negative 5 halves. Negative 11 halves plus negative 5 halves is negative 16 halves, which is negative 8. Okay. Negative 8 times negative 5 halves is positive 40 halves, which is just positive 20.
And then negative 25 plus 20 is negative 5.
Negative 5. There you go. And negative 5 times negative 5 halves is positive 25 halves. And so negative 27 halves plus 25 halves is negative 1. And so we got our answer, but we're not quite done yet. Here's the thing that one last step. So we're going to follow the same rules we did before, right? The numbers out to the left of the bracket are the coefficients. So let's start at the right and work our way across. So we've got a coefficient of, we got a constant, coefficient of x to the 1, coefficient of x squared. And if I had more numbers, it would be the coefficient of x cubed, x to the 4th, etc. But we stop in this case. So we end up with a 1x squared minus 8x minus 5. Okay, there's the polynomial part. And negative 1 is our remainder. That's what remains over the denominator. Well, our denominator, as we've got this written now, our denominator is x plus 5 halves, right?
Correct.
Okay, so I get a negative 1 on the top and an x plus 5 halves on the bottom. But that's really inconvenient. We don't want to have a fraction on the bottom. So what we're going to do then is we're just going to clear the fraction on the bottom and the top by multiplying the top and the bottom by the same thing. Well, what would I have to multiply the bottom by to clear all the fractions? There's no, it'd be the the least common denominator. Well, there's only one denominator, which is a 2. So we'll just distribute a 2 through. 2 times x is 2x. 2 times 5 halves is 5. On the top, I get 2 times -1 is -2. So really that last step, it's always going to be this way. You notice what we did? We just undid this first step we did up here. We divided out the 2's at the beginning. Now we're going to distribute that 2 to the denominator and the numerator in this last term. So I end up with a -2 divided by 2x plus 5. Does that make sense?
Yeah, that makes a little bit more sense.
Okay. You want to try one like that?
Sure.
Okay. So let's do, well, okay, here's another example. So like, let's look at this one real quick, because you might actually have more of them like this. Did any of yours, when he went through them, did he ever get any that were that hard, where you had fractions?
No, he didn't do any fractions.
Okay, right. So his are all going to work out probably like this instead. Okay.
Yeah.
So his will be like probably stuff like this. Now, in this case, if I were to do the same process, if I were to factor a 2 out of the top and the bottom, because I need to divide the bottom by 2, don't I? Because I need that to be a plain old x. So whatever the coefficient of x is, we're always going to factor that out. Okay. So if I undistribute a 2 from the bottom, there's my 2 that I factor out. I'm left with, well, 2x divided by 2 is x. -4 divided by 2 is -2. On the top, when I undistribute a 2, I get my 2 out front, which I can cancel. And then I'm left with 4x squared divided by 2 is 2x squared. -6x divided by 2 is -3x. And 10 divided by 2 is 5. So what happens is, then I just get a simpler synthetic division problem to do. No fractions.
Then this would do 2 divided by 2, -3 and 5.
Exactly. Yeah. And now we would just do a regular, really all we did is we just reduced this fraction. We just divided the top and the bottom each by 2 to make it easier, because that's a number that divided into everything in the top and the bottom. But the best way to think about it is we factored a 2 out of the top and we factored a 2 out of the bottom and canceled them, because 2 divided by 2 is 1. Okay. And that, I'm sure that's how his problems are going to be.
Yeah, his are pretty easy.
Yeah. Does that make sense?
Yeah.
Okay. So let me see. And if you don't, I mean, if you feel like you got it, don't feel like you need to sit here and go through a problem. If just to, I mean, really, I mean, if you got it.
Yeah, I think I have it.
Okay. Well, then go ahead and, I mean, if you don't need to go through anymore, I won't keep you. I'll be on tomorrow. I think tomorrow I've got a big meeting. I will schedule something. Either I'll skip tomorrow, depending on how many meetings I have, and I'll be back on Wednesday, or I'll try to find other time in the day when I don't have any meetings tomorrow. If you have more questions about this stuff.
Okay. If I have questions, I can just email you, let you know.
Yeah, that's fine. Yeah, just email me and I'll tell you what. Yeah, if you got a question, I'll find a time tomorrow at some point to get on and do this. And if I don't hear from you, or anybody else, because it goes kind of in waves. I mean, sometimes I'll get lots of questions and sometimes I get no questions.
Yeah.
Crazy. If I get some questions, then I'll schedule something for tomorrow. Otherwise, I'll just do it on Wednesday.
Okay.
So you think, I mean, because I'm happy to go through another one with you if you want to.
No, I think I get it now. I was just like really confused of how the guy was trying to explain it, and I was just like, I'm lost.
Does that make sense? There's some other stuff when you guys get into, when you get ahead here, when you get into the section, I'm just going to pull something up real quick here. When you get into, man, my internet is slow today.
Yeah, ours is lagging too.
When you get into the stuff on finding roots.
I already did that.
Oh, you already did that? Okay, so you're probably good then.
Yeah, I'm taking the Unit 5 test. Then
Oh, yeah. Oh, you're good then. Yeah. So if you got everything else, then you're probably in great shape, Tyler.
No,
So
I haven't done the synthetic
you're kind
division.
of ahead then. Yeah, that's good for you.
I just haven't done the synthetic division for 4 or 5 days. I just kind of forgot how to do it.
Yeah, no, that's no problem. Yeah, good for you. Yeah, you're quite a bit ahead. Excellent.
Yeah.
All right. Well, maybe I'll see you tomorrow.
Okay.
All right. Sounds good. Have a good one, Tyler.
Thank you.
See ya.
See ya.